Alright guys, here is the second problem in this assignment 1. Basically we have this part. It is subject to 3 forces: 30 kilonewton, 50 kilonewton and 75 kilonewton, and this is the geometry of the part. So we know basically that force 50 kilonewton. So what we're going to do basically, we need to find the stresses on this element H. So we're going to do like we did in the previous problem. We're going to take each force and then we're going to transfer that force into the cross section, and then we are going to find the corresponding bending moments and then torsional torques, if any, caused by each force of these forces. So what I started doing is basically I moved that force into the center of that cross section. So this is our cross section, and I started basically by putting that force 50 kilonewton into the center of that cross section. So moving the force, you have to move the moment, the corresponding moment to that force, right? So we know that that force basically is creating a moment that looks like that, and that moment is going to be equal to 50, right? Multiplied by the distance between that force, right, and the neutral axis about which you are calculating the moment. So here basically, you know, we have two neutral axes, this guy and that guy. So 50 kilonewton is applied with respect to this neutral axis, and the moment is going to be equal to 50 times 10 to the 3 multiplied by the distance of that 50, which is going to be 70 millimeters. So converting, so 50 kilonewton times 70 times 10 to the minus 3 is going to give you 3500 newton meter. Alright, then we're gonna start with the second force, basically 75 kilonewton. So you take that 75 kilonewton and then you're gonna put it at the center of your cross section. And what is the moment that this force basically does? It will be equal to 75 kilonewton times that distance 200, right? So, and that moment is gonna be like that. So that moment basically is trying to compress the material which is here, and then it's trying to basically rip off the material which is here. So this part is going to be in tension, and this guy is going to be under compression as a result of this movement. So I'm labeling these M1, M2, and then, you know, force P1, P2, and then last force, which is P3. So P3 is this, and then P3 is going to be equal to how much? 30 kilonewton. How about the moment that is caused by that 30 kilonewton? So we know this 30 is doing this, right? So we are going to have a moment that actually looks like that, and I'm gonna put that double arrow on it, and this guy is, and 3 is gonna be equal to 30 times 10 to the 3 multiplied by, what is the moment arm of this 30 kilonewton is gonna be equal to 100, right? So 100 times 10 to the minus 3. So 10 to the minus 3 and then 10 to the 3 will vanish, so I'm gonna end up with 3000 Newton meter. Alright. Okay, so we have put all the forces. So we have 3 forces and then we have 2 moments. So by the way, these 2 moments are going to cancel each other, right? Or not cancel each other. So this guy is going to be equal to how much? 75 times 200, which is going to be equal to 150, right? 15. 15,000 Newton meter, right? So I have 15,000 Newton meter on this end, and then 3,500 Newton on this end. So I'm gonna have one net moment, basically, right? Which is gonna be equal to the difference between those two, and it's gonna be in that direction. So and that basically the net moment in this direction, right? Let's call it M4, and M4 is gonna be equal to 15,000 minus 3,500 Newton meter, which is equal to 500 Newton meter. So ultimately we have one moment like that, and then we have one moment here, right? And then this guy is deducted from this to give you this M4, which is equal to 500 Newton meter. Alright, very well. So right now we can begin to look at the forces which are, and stresses basically, which are applicable or applied on this element. Just before, let's just put our reference frame on this guy, and our reference frame basically, which has to do with the axes that are involved on here, which basically looks like that. So this was our z, and then that was our y here, right? And this one is our x. Okay, so x, y, z. So we are going to draw the stresses on this element in the y and then z plane, right? So we can see the longitudinal stresses. There is no stresses in this direction, right? Maybe shear only, right? But along this direction, we're gonna have the longitudinal stresses. So let me draw this element like that. So this is our element, and this is our y, and then our z, or basically this is minus z, right? So positive z is in that direction. That doesn't really matter. Okay, so let us look at the stresses which are assumed positive. So positive, basically I'm going to have what? So here I'm going to, P1 is creating tension stress, so I'm going to have P1 over A, right? P1 over A. How about P2 and P3? P2 creates shear maybe, and then P3 also creates shear, right? But it's not going to be included here. And then how about that moment? That M3 basically is going to create tension on here, right? So plus M3 C over I, right? What is your C in this case? So C is going to be the distance from the neutral axis to the element. So C in this case is going to be that distance, which is half of 40, which is 20 millimeters. So 20 times 10 to the minus 3 divided by I. I is going to be the moment of inertia of this relative to this neutral axis, which, as you guys know, is 1 over 12. The base times the height cube, right? What is the base? Based on this neutral axis, the base is going to be this, right? So 1 over 12 multiplied by what is the base in this case? It is going to be equal to how much? 140, right? So 70. So we have 70, and then this whole thing is 140. So 140 times 10 to the minus 3, and the height is going to be equal to 40 times 10 to the minus 3, and thank you. So we got the first component is due to the force. Second component is again tension. Tension is going to be due to M3. And then how about this guy? So this guy is actually creating tension on this end and then compression on this end. So that would be minus. So minus M2 multiplied by C. So C is going to be the distance between the neutral axis where the moment basically lies to that point, right? The distance between the neutral axis and that point is equal to 25 millimeter. So M2 25 times 10 to the minus 3, divide that by 1 over 12. What is the base? So now we're going to flip them. 40 times 10 to the minus 3, 140 times 10 to the minus 3, and the whole thing is the power cube. And that is really it. So we have P1, right? P1, M3, and then M2, which are creating axial stresses on this element. And then how about the shear? So if you have any shear, basically, that's going to be caused by which value? So we have P2 and then we have P3, right? If you consider the stresses caused by P3, they are maximum at the neutral axis, right? And then it would be 0 here and then 0 there. So P3 does not create any shear stresses on here. How about P2? P2 it does, right? So we have shear over here. So the shear is going to be equal to what? It's going to be equal to VQ over IT, right? But what is V? V is going to be equal to 75 kilonewton, which is equal to how much? P2. Q is going to be equal to what? So Q is equal to Y times A, right? So Y is going to be, so this is your area that you are evaluating, and Q is going to be equal to Y bar. So Y bar is going to be the centroid of this area, right? So it's going to be Y bar times A, where what is Y bar? Y bar is going to be equal to how much? It's going to be equal to, so we know that distance is going to be 25 times 10 to the minus 3 plus half of that distance, half of this distance from here to here, which is equal to how much? Which is equal to 75 or 70 minus 25 over 2, right? So 70 minus 25 divided by 2 times 10 to the minus 3 millimeters. So this is your Y bar, and then your area is going to be the area of this portion, right? So the area of this portion is going to be equal to how much? So it is going to be equal to, so it's a rectangle, so 70 minus 25 times 10 to the minus 3 and then multiplied by the base, which is 40 times 10 to the minus 3, and this is in meters squared, this is in meters. So now you get your y bar, and then you have your a. How about I? So I is going to be equal to the moment of inertia with respect to this axis, right? So this is your neutral axis in this case, and then it is going to be equal to 1 over 12, 40 times 10 to the minus 3, and then the height is going to be equal to how much? 140 times 10 to the minus 3 to the power 3, and then this is in meter to the power 4. So we got y bar a, and then I, and then how about t? T is going to be the width, which is 40 times 10 to the minus 3 meters. So you have all the values that you need, and then v is equal to p2, which is equal to how much? Which is 75 times 10 to the 3 Newton. Okay guys, so this is how you should be analyzing this problem. So here simply just crunch the numbers and then get the value of the shear, and then that would be it. In terms of the exam, you know, I will be asking you obviously to solve some problems like that, like, you know, basic stuff, and it will be multiple questions exam obviously, and the answers basically, you know, there will be some discrepancies obviously in the answers. So even if if you have slight different calculations here, you would actually still get the answer correct, because there will be huge discrepancies. All right, so you won't be off by much, and it will be very simplified exam in a sense that you know, I will be asking you, you know, like several portions in different steps. So each step is going to be alone, where your errors won't carry from one problem into another, so they would be independent problems in a sense. Alright guys, so those of you who are concerned that you know, you get the method right and then the final answer wrong, you shouldn't worry about that, because it is going to be very direct and then very specific. Simple calculations, mainly I'm looking into that you understood the concept. Alright guys, so that is it regarding this problem.